Hi, my name is Bruce Silver of BPM Essentials. More than 2,000 students have gone through our BPMN training and over 800 have completed certification. Our training approach, which we call method and style, goes beyond the meaning of the basic shapes and symbols, but teaches additional constraints called style rules and a methodology for creating what we call good BPMN, models that convey the process logic clearly, completely, and consistently from the printed diagram alone. The right BPMN tools can make a big difference. In this video, I want to show you how Process Modeler for Visio's new Method and Style Wizard simplifies creating correctly structured models. BPMN is inherently hierarchical. A subprocess, such as fulfill order, can be rendered collapsed as a single activity, as in this top-level diagram, and also expanded as a process in a separate child-level diagram. In a BPMN tool, these process levels are hyperlinked together, but not in the printed output. One key to good BPMN is use of label matching conventions to visually connect the process levels. In method and style, each end event of a subprocess denotes a distinct end state, and a subprocess following the gateway in the parent level tests which end state was reached. Label matching links each child-level end state to one of the gateway outputs, called gates. Just to quickly illustrate how this works, the child level of fulfill order has two end states, fulfilled OK and out of stock. Since there are two end states, we label the gateway fulfilled OK, ? And the gates are labeled yes and no. Alternatively, we could have left the gateway unlabeled and labeled the gates fulfilled OK and out of stock. This label matching is an example of a style rule, and tools like Process Modeler for Visio and also Signavio have style rule validation built in. In one click, you can see not only violations of the rules of the BPMN spec, but also those of the style rules. Adding labels in this way may seem like a lot of bother, so what's the point? Look at this example. In the top-level diagram, the user sees fulfill order followed by the question, fulfilled OK? But what does fulfilled OK mean? From the top-level diagram, it's not yet clear. When we drill down to the child level, we see it means instances that reach the end state labeled fulfilled OK, which are those that are in stock. The label matching between parent and child diagrams is a mechanical device that guides the user even when he or she is completely unfamiliar with the process or the modeler's terminology. And we also have a similar label matching convention for message flows on parent and child level diagrams. Style rules help clarify the meaning of the printed diagram, but creating well-structured process models consistently is harder. It requires a methodology that asks modelers, often business users, to think a little more like architects, which is top-down and abstract, rather than their normal comfort zone, which is bottom-up and concrete. The new Method and Style Wizard addresses that difficulty by automatically generating the BPMN based on a structured interview. The wizard follows the top-down methodology. First, it asks how the process starts. That identifies the process instance and its possible end states. That scopes the process. Next, it asks you to decompose this process into 6 to 10 steps, a small number so the whole process at a high level fits on one page. Every action in this process must be inside one of these steps. Moreover, each step must be a BPMN activity performed once per process instance. This decomposition is hard. It's a completely different way of looking at the process from what happened next. The modeler records the names of each activity, verb, object. Also, if there is more than one way the activity could end, affecting what happens downstream in the process, it asks you to enumerate the activity's end states, noun, adjective. Next, it asks you to link each activity end state to what comes next. These are just lists because at this point we don't want the modeler thinking about the mechanics of drawing the diagram at the same time he's doing this new hard thing, the decomposition. But realize that once this list is done, we have essentially everything we need to create the top-level diagram. We have all the activities, the start and end events, and the gateways defined and named already. In principle, the diagram could be generated automatically, and that's exactly what the wizard does. Now the cycle repeats for each subprocess. What are its steps? Enumerate the end states of any steps that have more than one way to end. And the wizard then generates the child level diagram and does all the proper matching of end state and gateway labels. And at the end, the wizard asks about message flows and adds those as well, again implementing all the style rules. So the wizard takes modelers away from thinking about the mechanics of diagramming, which they often do incorrectly, at least when first learning BPMN, and the extra bother of things like label matching required by the style rules. It gets them instead thinking about the things that are in the end more important to achieving a structurally correct, consistent, hierarchical model that is clear to someone who does not know the process or the modeler's terminology. This is the win. The scenario we use in class is the order-to-cash process for a new car dealer, an oversimplified version of it. The process starts upon receipt of an order from the customer, specifying the details of the car, the price, etc. And it ends when the dealer receives full payment and the customer drives off in the new car. Upon receipt of the order, it is first finalized, either by reserving the car in the dealer's stock or the customer committing to a custom order from the factory. If it's already in stock, it is prepared for delivery by the service department. And when it's ready, we complete the transaction and the process ends. If a custom factory order is required, we need an activity, acquire car from factory. That normally ends when the car is received from the factory, after which it is prepared for delivery and the transaction closing. But if the factory cannot deliver the car in a timely way, the customer could cancel the order. In that case, we need to handle the cancellation and end in the exception end state, order canceled. That's the scenario. We want our top-level diagram to have these 5 activities shown here with their internal details drawn in child-level diagrams whose end states match the activity end states shown here and also match up with the gateway labeling. All right, so let's see how this looks in the tool. We go File, Process Modeler 6, Method and Style Wizard, and we put in the model name demo, the process name, order to cache, starts on external request. The name of the message is order. The requester is customer. The normal end state is transaction complete, and we'll add a second end state, order canceled. Click Next. We'll add the activities. First is finalize order, and it has 2 end states. Remember, the first one is called reserve from stock, and we'll add a second one called custom order required. This is done by the sales department for the lanes. We'll add the second one, acquire car from factory. That also has 2 end states, car received and order canceled. So we enter those. That's done by the finance department. Prepare car for delivery. That only has 1 end state, so we don't need to enumerate it. That's done by the service department. What else? Complete transaction. 1 end state. That's done by the finance department. And handle order cancellation. That's done by the finance department. 1 end state. So that's all of our activities. Click Next, and now we can match each end state to the next activity. So reserve from stock goes to prepare car for delivery. Custom order required goes to acquire car from factory. Car received goes to prepare for delivery. Order canceled goes to handle cancellation. Prepare for delivery goes to complete transaction, and that goes to the end state, transaction complete. Handle cancellation goes to the other end state, order canceled. And click Preview to see if this looks right. This generates BPMN. Yes, that looks right. We'll have a chance to fix this up, make it a little neater later. Click Next. Now let's model the child level of each subprocess, starting with acquire car from factory. First activity, place the factory order. Then we're going to receive the production date, which could be either normal or delayed. So we'll add those two end states. We'll only need to do this if there's more than one. And we have an activity, if it's delayed, to calculate the new closing date and then confirm the closing change with the customer. And that could either be confirmed or canceled. So add those end states. Wait for the car, assuming it's not canceled. And I think that's it. So now we map the end states to the next activity. Factory order, receive production date. Production date normal goes to wait for car. Production date delayed goes to calculate new closing date, which goes to confirm closing change. Confirm goes to wait for car. Cancel goes to end state order canceled. Wait for car goes to car received. So that all looks good. We can preview the child level. That looks pretty good. And now we click next and we go down to model the message flows for acquire car from factory. We already have the customer, but we need another participant, another pool called factory, so we'll add that. Now click add message flow, place factory order outgoing, a message called factory order going to the factory. Add a second message flow on receive production date, incoming, which is the production date from the factory. Let's see, what else? We have to confirm with the customer. So confirm the closing change outgoing to the customer is the closing change request. And at that same activity, we have an incoming, the closing change response from the customer. Okay, that's it. We'll click create and we'll generate in Visio the top level diagram and this one child level diagram that we just specified. There's the preview. Let's close that. Here's the actual Visio. And notice we have the pools, the customer, the factory pools, order to cash process pool. We've got the message flows there. We can clean it up in Visio, sort of move the sequence flows out of the gateways to make them a little neater. We can click the text block tool to move labels, like to move the message flow labels kind of in the white space in between the pools, and move the gateway labels a little closer to the gateway. So let's see, I'm moving the message flows here just to make it a little easier to read. And all right, move those gateway labels. And here you have the whole thing. If we right click and expand that subprocess, here's the child level. And notice we have the same 4 message flows in the parent and child level with the same labels satisfying the style rule. So that's the wizard in action.